Practical knowledge, the cornerstone of civil engineering. Civil engineering is a field where theory meets practice. We design and build structures that stand the test of time. It's not enough to just understand the formulas and equations. We need to know how to apply them in the real world. That's where practical knowledge comes in. Practical knowledge is gained through hands-on experience, observation, and learning from seasoned professionals. One crucial aspect of civil engineering is foundation design. The foundation is the very base of any structure. It transfers the load of the building to the ground. A strong and well-designed foundation is essential for the stability and safety of the entire structure. Without a proper foundation, even the most impressive designs can crumble. In this essay, we will delve into the practical aspects of raft foundation design. We will explore the step-by-step process, from site investigation to construction. We will also examine common mistakes and how to avoid them. Whether you are a budding civil engineer or a seasoned professional, this essay will provide valuable insights into the art and science of raft foundation design. A raft foundation, also known as a mat foundation, is a type of shallow foundation. It is used to distribute the load of a structure over a large area of soil. Imagine a large, thick concrete slab that supports the entire building. That's essentially what a raft foundation is. Raft foundations are used when the soil conditions are poor. They are also used when the building loads are very high. For example, if you are building a tall building on soft clay soil, a raft foundation would be a suitable choice. Some real-life applications of raft foundations include high-rise buildings, heavy industrial structures, and even residential buildings on expansive soils. Understanding the principles and practical considerations of raft foundation design is crucial for any civil engineer involved in building construction. Before we even begin to design a raft foundation, we need to understand the ground beneath our feet. Site investigation is a critical step in the design process. It involves collecting data about the soil conditions, groundwater table, and other subsurface features. There are various methods of site investigation. These include boreholes, test pits, and ground-penetrating radar. Boreholes involve drilling into the ground to collect soil samples. Test pits are shallow excavations that allow for visual inspection of the soil. Ground-penetrating radar uses radio waves to create images of the subsurface. The data collected during site investigation helps us determine the bearing capacity of the soil. It also helps to identify potential problems like expansive soils or high water tables. This information is crucial for designing a safe and stable raft foundation. Section 4. Calculating loads. Ensuring your foundation stands strong. Once we have a good understanding of the ground conditions, we can start calculating the loads that the raft foundation will need to support. This is a critical step in the design process. If we underestimate the loads, the foundation could fail. There are two main types of loads: dead loads and live loads. Dead loads are permanent loads that do not change over time, such as the weight of the building itself. Live loads are temporary loads that can change, such as people, furniture, and wind loads. We use various codes and standards to calculate the loads. These codes provide guidelines based on the type of structure and its intended use. Accurate load calculation is crucial for determining the size and thickness of the raft foundation. Section 5. Designing the raft from concept to concrete reality. With the loads calculated and soil conditions understood, we can now move on to the actual design of the raft foundation. This involves determining the dimensions of the raft, the thickness of the concrete slab, and the reinforcement details. Reinforcement, typically in the form of steel bars, is embedded within the concrete slab to provide tensile strength. Concrete is strong in compression but weak in tension. The steel reinforcement helps to resist the tensile forces that the foundation will experience. Today, we use sophisticated software to aid in the design process. These software programs can analyze complex load combinations and generate detailed drawings. However, it's important to remember that software is just a tool. The engineer's judgment and experience are still crucial for ensuring a safe and economical design.